Arizona Science is supported by Research Corporation for Science Advancement.
For Arizona Public Media, I'm Leslie Tolbert, Regents Professor Emerita in Neuroscience at the University of Arizona, and this is Arizona Science. Our guest today is Tom Zega, professor in the university's Lunar and Planetary Laboratory. Tom's an expert in analyzing materials that come from meteorites and asteroids to help us understand the history of our solar system. Tom, thanks for joining us today. I'm very interested to hear about the tools that you use for analyzing material and then also how you analyze it. What's the big question you ask?
Yeah, thanks, Leslie. It's a pleasure to be here. It's a real honor. I'm a fan of the Science Friday cast, so real pleasure for me to be here. The big questions are always focused on origins. You know, where did we come from? Where did the materials that make up our solar system come from? What were the kinds of chemical pathways that led to their origins? Can we quantify the conditions under which those chemical reactions happened? Do we understand the chemistry that prevailed before Earth was formed and ultimately led to the formation of the planets, including Earth? These are the nature of the kinds of questions that we ask when we study the materials that either are returned to us at the mercy of what falls from the sky, i.e. meteorites, or dust particles that are sampled in the Earth's upper atmosphere, which NASA collects, as well as samples that are returned by missions such as OSIRIS-REx.
So we'll talk about OSIRIS-REx in a few minutes. But first, tell us how you analyze the material that you have.
Typically, when we start out looking at a sample of a meteorite or a sample that's returned from one of these missions, we will actually look at it with a visible light microscope that I think is familiar to most of us who have taken any kind of high school science, right? And so the visible light microscope will provide us with sort of broad scale information on the sample. It'll give us context. We can start to see textures, which may provide insights into what else is in the sample, what the heterogeneities are, and what we might want to probe at much higher levels of scale. And so that's where we'll start out. But eventually we'll make our way to electron microscopes, and we will look at the sample at increasingly smaller scales with electron microscopes until ultimately we get to the atomic level, and then we're looking at individual constituent atoms and the different mineral phases that make up the sample.
You'll be getting material from Bennu when it comes back. Can you tell us about that project?
The sample is on its way back to Earth as we speak. It will return in September of this year. It will be curated at the NASA Johnson Space Center, and then separates and allocations of it will be made by the curatorial facility at Johnson Space Center to laboratories around the world. And obviously, the University of Arizona is among the groups that will get material. And there's a set of instruments here on campus that will be brought to bear on trying to understand the detailed chemical and structural makeup of these samples so that we can answer questions on origins, both questions that are asked about the origins of material within the solar system and even material that formed outside of it before the solar system formed.
Wait, tell us how that works.
So in meteorites, we have found tiny grains of dust that formed in the gaseous envelopes around ancient stars. They're actually grains of material that are pre-solar. They formed before the solar system formed itself. And we have ages on the solar system of about 4.57 billion years. And so these grains, because they formed in ancient stars, are even older than that. And so we can find them in meteorites by measuring their detailed chemistry. So we look at both their element composition as well as their isotopic composition. And those signatures tell us whether or not something may have actually formed outside of our solar system.
Oh, that's absolutely fascinating. Thank you so much.
Yes, thanks, Leslie. It was a pleasure to be here.
Tom Zega is an expert in using very high-resolution analysis of extraterrestrial material to reveal the deep secrets of how our solar system formed. You can listen to this and all Arizona Science conversations at azpm.org/Arizona Science. I'm Leslie Tolbert.
Thank you to Research Corporation for Science Advancement for their support of Arizona Science.